Alright, this is INST 239, lab number 7. We are adjusting a PID controller in TIA portal. So this lab we've already actually started. We've done section 1. We installed an analog output card. That part has already been done. We actually created a PID control block before. What we're going to do is we're going to modify this from a level control into a flow control. And so we'll show you what I've done here. And we'll go from there. So the first thing we want to do is we want to update our tag table, and so we updated this. This was originally set up for level control, not flow control. So we have our flow raw coming in here. This is the actual input from the analog input device from the flow meter, and then we scale that from a range of 0 to 1. And that becomes our flow reel, and then we apply the same range as our flow meter, 0 to 6 gallons a minute, and that is done here. The next one that we have listed here in the lab is our output, which goes to our valve. We label that as FV100. You can see that here in the tag table. And then we have the other ones, should be carried over from the previous lab. PID output, it's going to be output of our controller. We have a couple of additions. For this, PID state tells us whether we're in manual or automatic position. It gives us a feedback to the operator. Manual value, our last lab we just put this in straight from the ladder logic page. This gives the operator the value to put in a place for where they want the control valve to be at when they're in manual mode. PID reset allows us, if there's any errors, allows the controller to be reset by the operator. Manual bit is added, and then error status as well. So it gives us feedback to let us know if there are any errors with that. And then the manual bit just basically turns the PID controller from automatic to manual. That's not new. That was in the last lab as well. So after we get all of our tags updated, then we update the ladder logic. And so the ladder logic is updated just by basically adding a few things here to the PID compact block. Manual value, before this is where we would just input the number, but the operators couldn't have access to this obviously, so we had to add in a tag so that they could access this from the HMI. PID state and error status were added as well. Everything else is just change the label of it. Left output bias in here from our proportional only controller. However, if you go down here, we're not giving it any value. I could just delete this block, but in future labs we might use it again. But we made sure that this was 0 because the previous lab it was a proportional only controller, and this one will be a proportional integral controller. When we're using flow, we want to use integral instead of an output bias. And then also note on the lab that we will not be using derivative control for this because flow control is generally too noisy to add derivative control. So this was a proportional integral, or PI controller. Okay, so this is all basically just renaming a bunch of tags and adding some things like this. Take out the output bias, and we'll have the integral control instead. Here we had to change the scaling. We were at a flow meter to this we were at a level meter at this input, and now we're changing it to a flow meter. So our values here have to change. So we change those accordingly. This meter will read anywhere from 0 to 6 gallons a minute. Okay, after we did that, then we went into our controller properties here. Just simply click on the PID compact, open up properties. It was already open, so that then closed it. So we open up properties and we change the settings here. Instead of being set up for general, we change it to flow, gallons per minute. This is going to be a direct acting controller. Okay, so you can work out the function that you know from class to be able to determine that. This will be a direct acting controller, so we don't want to check the invert control logic. So if we were doing a reverse acting controller, we would invert that. But where controller types can be flow, gallons a minute, process value, it defaults to 120, so we change that to 6. Input-output parameters using our set point and our scaled flow, and the output's going to be the PID output there. That is pretty much it from the controller side. Assuming everything works, we'll come back and do a little bit of commissioning for it. But next thing we want to do is we want to set up the HMI. So we have our HMI screen here. And so we added some things we didn't have in the last lab. So we took this input-output field and changed that to flow. Okay, because that's now going to be flow instead of level. Set point still be. We added this box. This becomes the set point, so we add this to the tag set point. Just to refresh your memories how we do that, we just go into whatever tag we want to have. Do we find it here? And then select it. Make sure you're in the PLC tags, so you don't have to make up a whole bunch of new HMI tags. Just go into PLC tags, and then it should be there. And then if we want to change the display here, we'll just leave it like this for now. We could. That allows the operator to input a set point, and then when we want to put it in manual control, this allows the operator to change the control valve directly in manual control. Automatic control, it's going to be comparing the process value with the set point, making adjustments. Manual, it ignores all that, and the operator just puts in a number here. Then this gives us a feedback as far as what the valve position is open. Okay, since this is an air to close valve, a fail open air to close valve, that means the number that the PID block actually gives it will be telling it percent closed. And most operators are used to looking at this as percent open, and so that's where we go back into the ladder, and we just take a 100 minus, take that value minus 100 minus the value closed, gives us a value open. So if it's 0% closed, that means it's 100 minus 0 or 100% open. There's other ways to do that, but that's just a quick and easy way to be able to do that for this lab. Okay, and that should be good. We are going to change some of these once we get up and running. The proportional gain, we'll have to do that on the lab. I want to see how kind of all this works, and then we'll go over some of these values here. So let me go ahead and get us running here by going online. This isn't really going to be able to see very much easily, but I don't have a camera, but I got a potentiometer set up to be able to adjust my flow in 1.92. As you can see, starting to change, go around a little bit. My set point's 2, saying I have 3 gallons a minute. One thing we can do to see this a little bit better is we can open up this commissioning screen. Let's see what we got here. Okay, and as you can see, as the input changes and the set point changes, set point doesn't change, the output's changing accordingly. And if I want to change the controller into manual, I can do that. Changing into manual mode with my toggle switch, and then that changes the output to do whatever the operator says. And with the touch screen, I can change that just to 50% open. Now we have our toggle switch on our controller to be able to do that. Switch it from manual to automatic. Okay, And the flow rate changes accordingly. If we change the potentiometer. So now you should be able to answer these questions. So go through the lab, open up the lab on Blackboard, go down to section 7. There's 10 questions. What we can be able to answer after watching this video going over the lab. And then what we want to do is a couple of calculations here. If we have a control range of 1 to 2 gallons a minute, so if we want to control this between 1 to 2 gallons a minute, but the flow meter measures 0 to 6 gallons a minute, you should be able to calculate the gain, proportional gain for that, and then you should be able to calculate the proportional band. It should be in chapter 36. Should be able to give you the answers for that, and then some of these other ones, if you don't know exactly right at like number 8, number 9, number 10, you'll be able to find those in chapter 37. The other ones should be able to find just by watching the video. If you need a little bit of help, then this will be found in either chapters 36 or 37 in your textbook.